The invisible rule that decides everything. There's a rule you obey every second of your life without ever noticing it. It governs motion, balance, and change, yet it never announces itself. And once discovered, it quietly rewrote how reality is understood. To see why this invisible rule matters today, we need to look at how humans try to make sense of chaos. The universe appears noisy and unpredictable. Objects collide, systems fail, energy spreads. For a long time, this randomness felt fundamental. But beneath the disorder, physicists suspected something deeper, a principle that did not care about shape, scale, or material, a rule that stayed the same no matter what else changed. This suspicion grew from simple observations. A pendulum swings differently if shortened. A spinning object behaves strangely when disturbed. A falling body accelerates predictably. These phenomena looked unrelated, but their outcomes hinted at a shared structure. Something was being preserved, even as everything else transformed. The breakthrough came when scientists stopped asking what changes and started asking what is not. They noticed that despite motion, collision, and deformation, certain quantities remained stubbornly constant. They could be transferred, reshaped, or hidden, but never destroyed. The universe allowed endless rearrangement, but no loss. This realization reframed physics completely. Instead of chasing causes, researchers followed invariance. They discovered that behind every predictable outcome was a conservation rule quietly enforcing consistency. Motion obeyed it, forces respected it, even chaos bowed to it. This was not just a mathematical trick. It suggested the universe had an internal accounting system, one that balanced every interaction perfectly, whether anyone was watching or not. And once this rule was recognized, it became impossible to ignore. At first, this invisible rule seemed almost too abstract to matter, a bookkeeping tool for scientists, not a feature of reality itself. But the deeper they looked, the more universal it became. No matter the system, no matter the scale, the same pattern held. Something was always conserved. Energy could change form, but never disappear. Motion could shift between objects, but the total remained fixed. Even when systems appeared to lose order, the underlying balance stayed intact. The universe was not wasteful. It was precise. This idea challenged how people understood cause and effect. Events no longer unfolded freely. They were constrained by hidden limits. Every action had boundaries it could not cross. Every outcome was shaped by what had to remain unchanged. As experiments grew more extreme, this rule became even more dominant. In violent collisions, energy transformed into heat, light, and sound. In quiet systems, it flowed subtly between parts, but it was always accounted for. Nothing slipped through the cracks. This revealed a deeper truth. The universe was not governed by individual laws stitched together. It was unified by principles that operated everywhere at once. Conservation was not a local rule. It was global, timeless, relentless. And once this rule was accepted, it began to explain mysteries that once felt unrelated. Why machines could never be perfectly efficient. Why perpetual motion was impossible. Why some transformations required sacrifice elsewhere. The invisible rule was always present, limiting what could happen. What seemed like freedom turned out to be structure. What looked like randomness hid rigid constraints. And the universe, once thought chaotic, began to reveal a strict internal logic that nothing could escape. The conflict emerges when this invisible rule is pushed to its limits. Because if nothing can be lost, then where does disorder come from? Why does energy spread? Why do systems decay? The universe seemed to be conserving something, yet constantly sliding toward imbalance. This tension led to one of the most unsettling realizations in physics. Conservation does not prevent change. It demands it. Energy spreads because it must. Systems evolve toward states where balance is distributed, not concentrated. The rule does not preserve structure. It preserves totals. This distinction reshaped how time itself was understood. Certain processes could only move in one direction. Heat flowed outward. Order dissolved. Not because it was forbidden to reverse, but because doing so required conditions that conservation made overwhelmingly unlikely. The build-up toward this understanding revealed a harsh symmetry. The same rules that guarantee consistency also enforce decay. The universe remains balanced overall, but local order pays a price. Stability in one place demands instability elsewhere. This realization was emotionally jarring. It suggested that loss was not a failure of the universe. It was a consequence of its fairness. Energy could not be destroyed, so it had to spread. Systems could not hoard balance indefinitely. At this point, conservation stopped feeling comforting. It felt indifferent. The invisible rule did not protect complexity. It merely tracked it. And in doing so, it explained why time feels like it moves forward, why memory works one way, why aging, erosion, and collapse are universal. The rule that decided everything was not kind. It was consistent. And that consistency carried a cost that no system, no matter how complex, could avoid. The climax arrives with a realization that feels both elegant and unsettling. The invisible rule does not tell the universe what to do. It tells the universe what it cannot do. And within those limits, everything else unfolds naturally. Once this was understood, physics gained a new clarity. Predictions became possible not because the universe was controlled, but because it was constrained. Conservation laws became the skeleton holding reality together, unseen but unbreakable. This understanding reshaped technology, engineering, and science itself. It defined the limits of engines, the flow of electricity, and the behavior of matter at every scale. It explained why some dreams could never work, no matter how clever the design. More deeply, it changed how we think about progress and loss. Complexity is temporary. Order is local. Balance is universal. The universe allows beauty, but it does not preserve it. It allows structure, but it does not guarantee it. Today, this invisible rule still governs everything you touch. Every step, every breath, every heartbeat obeys it without exception. You live inside a perfectly balanced system that never breaks its own rules. Understanding this does not make the universe colder. It makes it honest. And once you see the rule, you start to notice its presence everywhere, quietly deciding what can happen and what never will. So, what do you think? Are we repeating the same mistake again?